Good afternoon, everybody. Welcome to the homework helper for 2.3. When we're looking at this one, the first thing that starts off with is we're looking at comparing rates of change in linear and exponentials. And when we're looking at rate of change, we're talking about ideas that are similar to our common difference or our common ratio. And we're looking to see what rate is going to be higher. So when we look at 1 here, it wants us to identify whether A or B has a higher or a greater rate of change. And so what we see is when we go up 1 on the x, how much are we going up on the y? We're going up plus 5. So we would say that our rate of change for A is 5 over 1, or more simply, 5. We got to make that connection to what's going on with this graph, and so what I have to do is I have to look to see where that it crosses at the perfect crosshairs. So I see that it crosses here, and nowhere else. So seeing that, I now calculate my change in my x, 1, right, plus 1, and then my change in my y, 1, 2, 3, 4, 5, 6, plus 6, giving me a 6 over 1 rate of change, or more simply 6. 6 is greater than 5, therefore B is my answer. This gets a little bit more complicated when we look at an exponential, but we can still figure it out very similarly. Here we have 2 graphs, so what we can do to calculate our common ratio is we can again look for 2 places where it crosses the crosshairs. So we have right here and actually right here. Okay, so and right here, oh, it's pretty good. So I can see that I go from 1, this is y is 1, to y is 2. What number do I have to multiply 1 by to get to 2? Times 2. So I see that my constant ratio is going to be 2 here, because I'm multiplying by 2 at each step. I'm going to do the same thing here. So I have here and then here. So this is 1, this is 2, 3, 4, 5. So I see that I multiply 1 by 5 to get here. So I'm multiplying by 5. 5. What's greater? Times 5 or times 2? Well, times 5 is very clearly greater. So that's how we do those. It'll give you word problems, it'll give you different things, but ultimately what we're doing is we're looking to find the common difference if it's arithmetic, or we're looking to find the common ratio if it's geometric, and figure out which one has the higher, or in this case, greater rate of change. So that's the first section. The second section is asking us, well, the topic is recognizing linear and exponential functions. So based on the given representation of function, determine if it's linear, exponential, or neither. And so let's do that. The population of a town is decreasing at a rate of 1.5%, decreasing by a rate, so it's shrinking 1.5% every year. That means we're multiplying by 1 minus 0.015 each time. Remember, this is how we calculate rates when we're working with percentages. That being said, we can know that this is going to be a geometric function, so we're going to say it's exponential. Exponential. And that's kind of like a hint. Whenever we see this 42 or 4.25%, when we're seeing percentages, that tends to be an exponential growth. Whereas when we look at something like 8, 3x plus 4y equals negative 3, while that doesn't look like anything we've done to this point, we can actually tell that this is going to be a straight line, because if I solve for y by subtracting 3x, I get 4y equals negative 3x minus 3, divide by 4, divide by 4. I get y equals negative 3/4 x minus 3/4, and that's a linear equation. Okay, so it's just asking you to think about that. And then finally, we're going to go back in the Wayback Machine and talk about geometric means. How do we find these numbers in between? And remember, one of the things that we're doing is we are inventing equations. We are creating equations. So I know for this one here for 12, I know this is going to be 2 times r to get here, times r to get here, times r to get here, times r to get to 162. Okay, so I know that 2r to the 4th equals 162. I'm going to scoot my paper over so we can do a little bit more work. Okay, I'm going to rewrite it here. 2r4 equals 162. And I got r to the fourth because I'm multiplying by r times r times r times r. I'm multiplying by r 4 times. So I can divide by 2, r to the fourth equals 81. So then I need to take the fourth root, which I think is 3. I think it's 3. I'm pretty sure it's 3. I think r is 3. Right? 3 times 3 is 9 times 3 is 27 times 3 is 81. Yeah, hey, I just knew that. But if you didn't, you can plug that into your calculator to solve that. And so now we can just fill it in, because 2 times 3 is 6, times 3 is 18, times 3, 18, times 3, it's 54. And if we did this right, if I multiply this times 3, 162, hey, what do you know? We did it correctly. So that's what we got. All right, and so that's what we're doing here. We're just setting up mini equations. Even if there's a fraction, even if there's a decimal, we can set up these mini equations. This one was easy enough that I could do it mostly in my head. These ones you'll probably need a calculator on just to make sure that you're getting it correct. But that's it for the homework for today. It's a weird week this week, so yeah. Get this done. See you tomorrow. We'll do the quiz. We'll have a 3-day weekend. Everything will be great.